In this video, we're going to look at an A-level maths exam question that uses the r cos formula. So I'm going to make one about the r sin formula as well. So be sure to look at that for my on my playlist. But it tells you an equation in terms of cos and sine, and it tells you that f of x can also be written in this format here. Let's start by replacing a with theta and b with alpha in our equation, also multiplying by r. So let's do that to start off with. Because after we've got this expression, we can compare it to the expression that's already given for f of x. So the first term would be cos A cos B, which is cos theta cos alpha, but you do have to multiply by the r, so it will be r cos theta, r and cos alpha. Sorry, I don't know why I'm stuttering. The sign is the opposite to what it is in the expression here. So because there's a minus inside of the bracket, it's going to be an opposite sign of plus, and then it's going to be a multiple of r sine A sine B, which is sine theta sine alpha. Now that we've expressed this format, let's write f of x in the other format directly underneath. So we can write it as 5 cos theta and then plus sine theta. We now want to compare coefficients, so let's do that. And I'm just going to not only change the color of the pen, but increase the thickness. Yeah. Okay, here both of these terms have cos theta, so we can compare the coefficients and we can say that r cos alpha is equal to 5. So let's start by forming that expression. R cos alpha equals 5. Looking and doing the same thing at sine theta, we can say that the coefficient of sine theta is just 1, and that's equal to r sine alpha. So let's write that out. R sine alpha is equal to 1. From here, we can get two things, the value of r and the value of alpha. To get the value of alpha, I'd recommend you do r sine alpha divided by r cos alpha. The reason for that is because the r's will cancel out, and you'll be left with tan alpha, and that will be equal to 1 divided by 5. If you do the arctan of both sides, you'll get the value of alpha. Do remember to put your calculator in radians mode, by the way. So arctan of 0.2 is equal to 0.197. Let's write it out to 3 decimal places. 0.197. Now that we've got the value of r, you can put it into any one of these two the value of alpha, we can put into any one of these two equations to find the value of r. So let's do that. Looking at the sine equation, we say that r is essentially just 1 over sine alpha. So that's 1 over sine of the value of alpha that we just found, 0.197. Putting all of that into your calculator, remembering again to put your calculator in radians mode, or leave it in radians mode if it's already in it, that will be equal to 5.1. Well, technically it's 5.099, so yeah, we'll write to that in decimal places because it is asking for 3 decimal places. What that means is that this whole expression here can be written as r, which is 5.099, and then cos of theta minus the value of alpha that we found, which was 0.197. Perfect. Let's now move on to how to use this in the next part of the question. It says, hence solve for this domain here. All of this expression, which we've already established can be written in this format, is equal to 2. So because we can write in this format, let's write in that format. And actually, I'm just going to erase pretty much all the work that we've done here, just so we have space for the rest of the work now, and I don't have to scroll down. Oh wait, I think there might be a better way. If I just select all this, yeah, great. Moving on to that next part of the question then. We're going to start by making the expression that we just found, 5.099 cos of theta minus 0.197, all equal to 2. We're then going to divide both sides by 5.099, so let's do that. You can then do the inverse tan of both sides, and when you do that, you get values of theta minus 0.197. So it's equal to the inverse cos of 2 over 5.099. When you put that into your calculator, I'm just going to very quickly do that. Again, I'd recommend you stay in radians mode. 0.099. That'll all be equal to 1.168. Now we also know that values of cos, they repeat. And where do they repeat? Well, if we draw briefly the graph between, you can use the cast diagram by the way, but if you draw the graph between 0 and 2 pi, if there's a value here, then the next value that it repeats would be here. And because it's reflective about pi, we can say 2 pi minus this answer will get you to this answer. So let's do that. On our calculator, we can do 2 pi minus 1.168. And when you do that, you'll get a value of 5.115. You might have thought to yourself, do we not have to change the domain? Because right now the domain is for theta and not theta minus 0.197. Yes, you're right. But the only thing is it doesn't really make a difference in this particular case, which is why I didn't bother doing it. But in some cases it might make a difference, so do be careful of that. Now that you got your values of theta minus 0.197, we're going to get the actual values of theta by adding 0.197 to both of these values. So let's do that. 0.197 would be equal to, well, the second value would be 5.312. And the first value, radians by the way, which you can write RAD for rad or just a C on the top right. And the 1.168 plus 0.197, just for that other solution, would be equal to 1.365. Okay, moving on. It says calculate the minimum value of when this expression, or this expression here in general. Okay, if we compare this to the expression that we did form, what's the difference? Well, the difference is theta is being replaced with 4x. So let's do that to our expression. Let's replace theta with 4x. So we can say that 5 cos 4x plus sine 4x specifically can be rewritten as 5.099 cos of, remember we said replacing theta with 4x, so 4x minus 0.197, close brackets, and then plus 15. If we now think about it, to find the minimum value of this, well, the minimum value of cos varies between -1 to 1. Cos and then to 1. That means that in order to make this whole expression as small as possible, we want this to be as negative as possible, because then when we add it to 15, it'll be the smallest number it possibly could be. In that case, we just want cos of this value here to be equal to -1. That make it so that this first term becomes minus 5.099, and then when you add 15 onto it, it'll get you the smallest value of this expression that's possible. So let's do that. Minus 5.099 plus 15 is equal to 9.901. The last part of the question says find the smallest positive value of x for which this minimum occurs. Well, that's where we really focus on making that cos equal to -1 and solving that for x. So let's do that. Cos of 4x minus 0.197 is equal to -1. That's where the minimum value occurs. Now, okay, let's do that. So doing the inverse cos of both sides, we get 4x is equal to the inverse cos of -1. Oh, sorry, not 4x, everything inside the bracket, which is 4x minus 0.197 is all equal to the inverse cos of -1, which when you put into your calculator will get you a value of pi. There is also the fact that cos values repeat every 2 pi, so the next one would be 3 pi, and the one before that would be minus pi. You might have thought, okay, can we use minus pi? The thing with that is, if you make x the subject of this equation, it'll be negative. The first positive, the smallest positive value of x is when we use pi as our solution. To get the value of x from here, you add 0.197 to both sides, so we get pi plus 0.197, and then you divide both sides by 4 to get the value of x. So let's do that. I'm going to cheat a little bit. It'll just be this expression here, and then we have pi plus 0.197 all divided by 4, which is equal to 0.835. And that's your final answer for this question. Of course, remembering the radians. Thanks for watching. I hope this video helped. Be sure to like and subscribe if it did, and yeah, I'll post a video about what to do when sine is involved next. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.